Thank you very much for coming here today, for taking the time, and you are welcome once more. Today is going to be really, really interesting because now we're going to a part that it's still a part of the basics actually, but it's more into analytics rather than how the program works in general. But instead of that, we're going to move how the program works, and we're going to use that to answer questions. So today we are going to start with importing data. To begin with, I will simply copy this and take it to our studio. Okay, so this was the script for yesterday. I'll create a new script for that. Save this as data management. Save. Yeah. And I'm going to paste this right here. Now, I'm going to teach us one shortcut. Of course, this is not relating to anything about importing data, but I'll just teach us a shortcut. I would like to comment out all this that I just pasted here. Usually, we just use the hash symbol like this individually, but if you take that, I would say I prefer to be lazy with simple things like this or mundane things like this. So I simply highlight everything and I press Ctrl+Shift+C. That way, it's simply it makes everything a comment. Alternatively, you can always use this option in code. Ctrl+Shift+C. This is it. Comment or uncomment lines. Yeah. Is this legible enough? Should I increase the size of our studio? Is this better or the previous state? Which is okay. Okay, this is better. Yeah. Okay, moving forward. I'll just break this down. Now, one thing we need to understand about importing data in general is we need to understand the type of data that we want to import. That's the first thing. And I'm not talking about data that we are collecting manually. Of course, data we collect manually, we record it in some digital form, maybe in a database or in a software like a spreadsheet, like Excel or LibreCalc or anything, only Office or whatever category, but a spreadsheet. Then also, we can choose to save them as CSV files. So I've mentioned a lot of different file types. So what this means is what? Importing data generally depends on the file and the file type. So for example, I will just start with flat files. And flat files are things like CSV. And when I say CSV, I'm talking about the extension of the file. If you look at my files windows here, we have install.r. This is .r, and this is .rproj. And when I'm saying .r, I'm talking the name, the alphabet that comes after the full stop here. And the same thing with this. We also have .md. Now, those alphabets that comes after the full stops, they are the extension types. They are what determine the type of file that we have. This .md now, it means it's a markdown file. You can see the logo also. This rproj, it means it's an R project. Then if we see this .r, it means it's an R script. Why this is .gitignore, it means it's a JIT file. Now, if I'm going to open this, but before I go there and just do a bit more, I told us to download the file that we have in this GitHub repository because that's what we'll be using. So I've cloned it into my local computer and I have that's what I'll be working with. And just to make us know, whatever we do today, I'm going to also upload it here. So if we check this masterclass, this is what we did yesterday. The script is already available online. So let me just close this. Now, we need to understand the file type. I've given us a quick intro into what extensions are. That is whatever comes after the full stop. Now I'm going to open my own file manager, and for good reasons. Because before we work with we need to know how whatever we are working with, how they work. For example, now this is data, and data, we have two types of data. We have two data. Yeah, we have adults and we have student performance. So two different files. Now, if you look at adults, we have .csv. If I'm going to open this by default, it's going to be my spreadsheet file application that we want to open this. But that's not the goal because we are not seeing the file in its raw state. So I'm going to try to open it with something else like Notepad, a text editor. So I have Notepad and Notepad++. Let me see if I have any other thing I can use. Just Notepad++. Okay, Sublime Text. I like Sublime Text. But let me just use Notepad because this is default for Windows. Now, once I open this, look at what we have. We have state gov, numbers. And now this is a lot. Different numbers, but we can dissect this. Let me see if I can. Okay, I've zoomed in on this now. Now, let's look at this. We have a number, then comma. Then we have comma separating the values. This is a .csv file from the name here, adults.csv, meaning comma separated values. So each value is separated by comma, meaning each column, this is a column, then this is another column here, and this is also another column. But let's look at this here. You see how long this is. So this is the part of the second column, since there's no comma in here, but this is the comma. So then we have another column here, just like that. And see the end. We have less than or equal to 50K. Then we have no comma here. This signals the end of that observation or that row. Each comma like this shows a column, and each one this way, it shows an observation or a row. So that's one thing we need to take note of first. Let's understand our file before we import anything. And for files, for some data that you come across, they do provide something that is called a data dictionary. To be honest, it's not all the time that we have the luxury of a data dictionary. But if you do have the luxury of a data dictionary, you are very lucky, because the data dictionary will tell you what your data is about, what each of the columns, what they represent. Okay, let me zoom this in. So it shows that this data was extracted from the Census Bureau database, found that, okay, I'm not interested in all this. These are all metadata. It's not our business now. We just want to import data. Okay, let's look at this. These are the different algorithms that has been tested with this. I think these are machine learning algorithms. This is not also of interest to us. But now let's see this part. This is what we're interested in. The first column is age. This is adult.csv here. So this column, 39, 50, 38, like that, that's age. Then we have work class. And here we see state government, self-employed, private worker. It's starting to make sense like that. Then we have FNLWGT, which I do not understand. I can check if there's a meaning for that here. FNLGLT, but there's no meaning for that. But it's just a continuous data type. Then we have education. Let me see the data itself. I do not know what this means. It might be like maybe something relating to their finance. I can assume it's their salary. Yeah. But let me check native country. For native country, we have United States, Cambodia. That is clear. Then we have hours per week. We have capital loss. So each of these things that we have here before the colon is the name of the column right here. Of the name of the column that we have here. So this race, each of these, they represent the name of these different columns. So when we want to import, we have an understanding of how we are going to import it. Let's further move into this other file, tests, adult tests, and let's open with Notepad also. Okay, and now this is interesting. 1x3 cross validator, but it's also showing something that we are familiar with, which is this. Yeah. So let's just try to import. This is enough talk from me. If you do have any question from what I said just now, please ask away. Any question? Okay, I would assume there are no questions. Okay, yeah. There are 3 ways we can import CSV file. CSV files in actually like 5 or 4 with RStudio. The first, we can come to this place under the file menu, then we click on import data. Then we can either choose to import with base R or with the tidyverse with R. So if I choose base R and I locate what I want to import, adults.csv in this case, and I click on open. Now you see what we have. We have each of them This is the original file, the way it looks like. Now we have each of them with V1, V2, V3. That means it has assigned a column name to it this way. That means for some files that we get, there are no column names. For other files, there could be column names. But since this is not having, we can decide to either stick with the default, or we can use the names that we have from this data dictionary. So it's either way. But what is usually advised is what? Just give your column's name, because as you keep on working, you won't want to think about what does V1 represent or V2 represent. So we are going to learn two things at once now, which is interesting. We are going to learn to import, and we are going to learn to add a name on importation, like that. So let's just import Wrangling first. And if we click on import, you see what we have. We have adults, this read.csv, then header equals to false, then view adult, like that. View adult is what opens this. So that is two codes which it has written for us. But since we are using the tidyverse package, which we installed yesterday, I'm going to start by loading the library, tidyverse, like this. And part of the tidyverse we have with R. Okay, can you guys see my screen? Please, if you can't see my screen, it would be nice for me to hear that. Okay, you can see my screen. That's fine. Now, let me take this down. Let's look at this. We have read.csv. This is default using this R, but now we want to use the tidyverse with R. So with R, of course, we can import it from here, which is import datasets. With R now. You see that the interface is a bit different. We browse also and just locate our file. This adult.csv, then open. It will give us a preview of the data. And let's look at this place. I think this is why I prefer this compared to this R. You see that it has already given us the code. The first thing it did is what? To import the with R library. But this with R library is part of the tidyverse, which I imported here. It's already a part of that, so there's no need to import it again. Then it shows us a code also that's read underscore. You see, it's different from the other one which we have with this R, which is what? Read.csv. This one is read underscore. So that's still method one. Method two is to use what we have under the environment pane here. You just click on import dataset. Then you see that we have the same option. Then you click on it again. The third option is to use what we have on files. You click on the file that you want to import. Then if it's a CSV file, I think this only works for flat files. Flat files are the ones that are compressed and saved somewhat in like a text file format, like they are separated by with commas, semicolon, or pipes, or tabs, or white spaces. You have the CSV, PSV, CSV2, CSV2, and various other formats like that. Now, if I'm going to right click on this, okay, if I'm going to right click on, oh, I think that doesn't work for this. It only works for something that is TXT, text file. So importing from here, it's not possible. Let me check for another data type. If I click on this, okay, it's not also possible, but it's also possible to import right from the files pane. That's the second option. But it will either be a text file. This now is just a dictionary, so this is not seen as a data. Let me go back. This is quite, yeah. So I have to right click. If I right click, it will show me the option to what? View file or import the data sets. And if I click on import the data sets, it's giving me the read-out version. And it will show me what this looks like. And let's notice what we have here. You see, it's a bit different from what we have with this R method of importation, because it turned the first row automatically to the column name. We have 39 state governments, but we know that these are values: bachelors, never married, something clerical, then what? Not in family, white, male, and United States. These definitely are not what? Column names. So what is the right way to go about this? Well, there are two ways we can go about this. Let's write some code now. Start with read CSV. Then we use the file arguments I will try to locate the file that we have here, which is adults.csv. So for that, I'm going to use the quotation mark. And once I press tab, it's going to give me a breakdown. It's going to show me a drop down. So what I can do is just simply scroll with my keyboard. And the interesting thing is, it's going to show the subsets of each folder that are within this my project. Now, so I'm saying adults.csv. This is what I want to import. So I'll press enter for this. Then next, it's giving us tips. We have co-names. That means, do we have column names? And that will be false. Co-names equals to false. The default is true. Then we also have, if you press tab, you see this option. Then this is asking for the column types. That's the specification. But let's leave this for now. I will just try to import this where it is. And look at what we have now. Instead of B1, B2, B3, and the likes, X1. So this is how the tidyverse with R represents all these unknown column names. Yeah, so the next thing that I have to do, since I know that these are not the column names, is I need to, one way or the other, try to add the column name. For that, I will use a function. It's a function, but more like a combination. It's like this with Control-Shift-M. I will get this percentage greater than and percentage. This is regarded to as a pipe. Let me put this in comments. This is the pipe. But this pipe now is part of this tidyverse package. But I want the default pipe that comes with R. So for that, I'll go to global options. Under tools, then I will check for a setting. I think somewhere in code. Okay, this is it. Use native pipe operator. So once I have that, I click on apply just to change the settings. Then okay. So now, once I press Control Shift and N, you see that it has changed from this percentage right and greater than and percentage to this bar and percentage like this. They are both the same. They do the same thing. They just only have little differences. Yeah. So with this, the next thing I'll do is what? I will set names. That's the next thing I'll do. And setting names will simply help me to what? Add names to the column. And since I know the name of the column, I can come to this part and simply copy these names. We have age, work class, and the rest. I'll copy everything and I'll delete the parts that I do not need. So native country, this way. Copy. Then for this, I'll put it in C. C is used to combine values together. For example, if you want to combine 1, 2, 3, if I press enter, I'm going to have an error. But if I want to combine them, I'll use C. 1, 2, 3. So I have 1 to 3 combined. Of course, there's another shortcut to get this 1 to 3. It's 1 and colon 3, like this, also 1 to 3. So using the C function, I will paste everything that I need outside here first. Then I'll just take the parts that we want to work with this way. Yep. Okay. Any question as I continue to do this ad labor? Clearing all these parts out. Any question?
Yes. I tried using the code just like you have to import the data. Okay. I got an error. I tried running it, but I don't know if it was wrong of me to run it.
I won't say it is wrong of you to run it. I would say it's even good that you even bring this issue up, because this is something that I'm hoping to cover at the end of the whole session. That will be the last thing we'll address. It's about how to properly get a project. Now, if you look at this place at the top here, you see I have our Masterclass. It's up there. It's a project. It's different from it's a bit different from what you have, right?
Yes.
Yes. So you know what you would do to ensure that if you want to run my code and make it work exactly as I have, you go back to your file manager. It seems you've cloned the GitHub repository already. So yes, you click on this .r approach. That's what
Okay.
the R project. When you click on that, it's going to open it. Then anything you run, regardless of where you cloned your when you cloned the masterclass into, it's going
Okay.
to always import the data that are within this folder correctly.
Okay. Okay.
Yeah,
Because
that's
what I did was to open more
the
like a new
script.
project. Then I imported in
Okay,
the data
okay,
from the file manager also.
okay.
So maybe that's what happened. Okay, thank you. I'm going to take it now. Thank you.
Yeah, just try that and see if it works. Yeah, so moving forward, now I've copied all this. Now I only simply need to put them all in quotes. This is where it gets a bit labor intensive. I need to put each in quotes and separate them by commas because they are all going to go into the C, this. They are going to go in here. So I separate each of them by comma and I give them a quotation mark each. Please, as I do this, if anybody's having any other question, you're welcome to ask, please. And while there are no questions, I'll keep on doing this. Yeah. So for some data, it's possible that you have this already added. What each column means. They are called the headings or column names. So if you have that already, you can just remove this part of the code, which is code names equals false. You can just remove that part of the code and it will import without issues. We'll see how to do that using when we get to importing Excel files. So we'll see how that works. So we have underscore here, okay, comma, and there's another comma here, capital loss. I'm changing the dashes to underscore because that would bring an error data. Then comma, then comma. Okay, so comma here. And once I run this, okay, it's saying that the size of NM, that is the names, is 14. And it must be compatible with the native size that I have here. That means the number that I have for this right here is 15. That's what it means. Let's check. Let's look at this on importation. You see the number of rows, 32,000. Then we see the number of columns, 15. So indeed, I'm one short. So I can just add salary class. Then also, we check the delimiter. This is column specification. The delimiter is what? Comma. Then it's telling us the data types. Yesterday we covered data types. It's telling us we have 9 character data types and 6 double data types. Then if you want to see the whole column specification, you can use spec, which I do not want to use for now. Yeah. So moving forward, I'll run this. And on running this, we see that the names is printed nicely. Now look at this marital status. If you check marital status here, we see that it is printed separately. The way it is printed is different from the rest. It's having these backticks, this and this. And that's why I was removing this dash here, because that will be seen as minus. So it's better to just use underscore. So I can simply just run it again, changing it to underscore. I'll see that this is gone like that. So I'm going to give this a name. I'm going to call it adult data. And then I'll run it. One thing you should notice is before I simply assign, this is called assignments. I think I covered this yesterday. Before I simply assign my data to any variable, the thing that I did was test if it's working. So people just try to import directly, then they get into error and they start trying to figure out what is wrong. It's best to test everything. We want to test first, then we give our data a name. That's a variable name. So as we've seen me do, I tested it extensively, see, okay, what is wrong, what needs adjusting. And once that is done, I assigned a name to it. And now my code is clean, like this. Adult data names. And if I try to print adult data here, I have it printed. You'll notice that it's not printing everything. And that's because, of course, this RStudio is large. If I want to see everything, I can use the function view and to give me a nice, like a spreadsheet-like view. of the data, adult data. And once I click on that, we have what we have here. On the right hand side, you see the age, you see the working class, their financial, education number, and things like that. Everything working as expected. So I'll close this and I'll close this. Now that's for CSV files. It works almost similarly for other flat file type. Either you are importing with, yes, let me just give us the list of the flat files. We have flat file, we have, and this is separated by comma. We have PSV. It's PSV, but it's also written as TSV or CSV. But the main thing is it is separated with pipe. So I rather just leave it as PSV to not confuse us. And this bar here, it's called pipe. We also have CSV2, and CSV2 is semicolon. That's another flat file. Then we have, which other one? We have a lot. We have tab. Yes, that's TSV. And tab usually is like this. Then also we have FWF, which is fixed width. That means they can either have two spaces, but the spaces will always show that this is the separation. Tab usually is either 2 or 4 spaces, but fixed width is just the data is always having a fixed width. That's the gist with that. So I'm going to comment this out, Ctrl+Shift+C, and I'm going to move all this to the top. And to do that, of course, you can cut and paste. So I prefer the easy things. You press Alt on your keyboard, then you just click the arrow button up. And once you do that, it will simply move to the top with each line. Okay, so we've successfully imported a CSV file, and this CSV file is having no names. So we've given it names. We've given each of the columns, we've given them names. So that's something that is also good. Now, if you look at this place, you see the files that we have. Now I've imported the same files twice because adults is the same as adult data, only that this adult was imported using the base R. So it's better I should just remove this to save my memory. To do that, I use the rm function. It's kind of intuitive. Rm, remove, rm, remove, remove, rm, like that. So, and I click on adults, I put the name, and once I press enter, you see it is out of there. If you want to clear everything, you just click on this brush. It will ask, do you want to remove everything? No, in this case, I do not want to do that. Yeah. Now we are going to see the other CSV file, which is this test data, because now if you notice, they are actually the same file. They have the same value type. So let's just try to import it. So we say adult test. And for that, we also use read CSV, the underscore. And I can decide to put in file, which is the argument name, or I can just simply use the positional argument. Since I know that file is what always comes first, I just simply put column, then I press my tab and locate what I want to import. In this case, adult test data, like this. And if I import this, now it's showing something more interesting. Yeah, the only thing I can see is there's problem everywhere. Problems, problems, problems. So what we'll do is we'll take these set names, we'll copy this, we'll use it also. And then I'll introduce a new argument. The arguments I'll be introducing is the skip argument. Very underrated, but useful. The skip arguments. Now, if I press skip, skip means that how many rows do I want to skip before I start? Let's check this. Now we have one row here. So the question is, do I want to skip this? Any number that I put there is going to skip the number of rows. So if I put 2 and I try to import, okay, it has imported this. Let me just put this down and just try like this. So we see everything. So let's see what we have. It's showing new names, 0, 0.2, like that. Then it's also 15 columns. Then it's having characters and what's double. And look at what it's using. private, HS grade, and the rest 50. And we know that these are not column names. That's why I copied and used the what set names. And now we see that it starts with what 28 local government 3369 like that. Let's check the file. 28. Where's the test? Here's the test data. Okay. 38 private. Look, okay. 28 local government 33. So that's what we have. One other thing, and that's because I skipped 2. I've skipped 1, 2, like that. What about if I skip 1? Or I do not skip anything, and I simply try to run this. It's bringing warnings. Then look at the only name. It's showing that we have only one column, which is this 1x3 cross validator. And that's definitely not the column name. This. And this is not the column name. So I need to skip that. This time I'll skip 1. And if I skip 1, we should add this as the column name now. So this, and run it. You see that it is the new column name, 226802. Let's check. 226802. So this is what it has used as the column name. And since we know that's not the name, we can combine it as the O now. And then we'll see that the right name is added, and also the first part is included rightly, like that. So I'll assign this back to our dot test. So that's how we import flat files. Next, we'll see how we can import Excel file. But I want to just make us know something. Importing files generally, some of the times you do not need to add them in your local computer. I'm going to go back to the key. And under the GitHub repository, I will locate our file too. We have adult, and this is it here, adult CSV, the same file that we have locally. But what I want to do now is just check the raw file under GitHub. Then I'll copy this. I'll copy this link. And now if I try to read CSV, and paste the link here, it's quite long. If I run this, we see that it will also pull it. The only thing is we saw it download the file. So the message here is, you can use links or you can use local files, depending, anyone that you want. But this is having the capability to what? The capacity to download files from the internet and what? Load them. So that's the other part I want to show. Now to Excel files or spreadsheets. Now for spreadsheets, we have some big players. We have Microsoft Excel, quite popular. We have Google Sheets. We also have open documents, something, sheets or so, but it's ODS. So this is usually .xlsx. Why this is usually on the internet. That's Google Sheets. It's usually on the internet. Then we have open documents. This one is .ods. That's the extension. This, we won't work with this open document sheets. I'll just leave this here. We won't be doing anything with that. So now for Microsoft Excel, I do have an Excel file here, and that's under student performance. We'll be working a lot with student performance. So if I click on this view file, it's opening my spreadsheet already. And yes, we can see all this. This is the column name, and this is right. And this is how the file look like. So now we want to import this. To import that, we'll use a different package. The package is called read Excel. Yeah, and you can see it. It's also a part of the tidyverse. But the thing is, it is not imported as a part of the tidyverse. It is only downloaded. Anytime I press library tidyverse, it will not load this. So now I can load it. Library read Excel like this, and I'll take this. Okay, I've already run this, so I'll take this to the top since I'm still importing the package here. And this is what code organization. Anything you want to import, just put it at the top of your script. Now back to our Excel file. So to read, we have like 3 functions that we can use within read Excel. We have the read Excel. This one will read any type of Excel file. Then we have read XLX. That's if you know the extension. Then we have read XLSX, like that. Now, if you see this is XLSX. So it's this that we are supposed to use. But since I do not want to stress, I always use read Excel. We are going to use read Excel and read XLSX. I have no XLS file here, so I'm going to delete this. Yeah, so read Excel. What I'm going to do is I'm going to locate this student's maths data. And for that, I'll move to data/student. I can press tab, of course, and fill it up automatically. Student maths. Then I run this. Then we'll see that this is imported correctly. We have school, age, and everything. So I will call this math score. And I'll save it. Alternatively, we can use read XLSX. You see that we have the same thing. Data, students, performance, then student maths. This is exactly the same. So I just simply use read Excel, because if I see XLSX, I know it's Excel. If it's also XLS, it's Excel. This will simply just choose for me. So this is the gist with math score. So yeah. Any question before I proceed? Questions? Okay. If there are no questions, I can move on then. So reading Excel file is quite easy. It's also having other arguments. Let me put this down. Then the first argument is path. Path here is similar to the file that we have up here. The path is similar to the file that we have up here. That is the location of our file. That's what it means. Then also we have other arguments too. Since this is an Excel file, we have sheets as an argument to show which sheet we want. I think I've closed the file. Let me just open it again. And I'll create a dummy sheet. Now this is only one sheet. So I'll create a dummy sheet. I'll just copy this. And I'll put it in the new sheets. I'll call this new sheets. Then I'll paste it here. Then save. Use Excel format. Save. Then I'll close. Okay, let me just minimize this. Now we have sheets. Let me leave this like this and show us something. So we have read Excel now. The part is still also data, students, and student maths, comma, the sheets. This is where we decide which sheets we want to import. We have 2 sheets in this workbook. If I click on one, it's going to import what we had before, the normal thing. If I click on 2, it will import the next thing, which is the new one I created recently. Yeah. Another way we can go about this is, instead of using the sheet number, we can use the sheet name. We have sheets, new sheets like this. I think that's what I saved it as. So if I run it, you see that we also get the same thing. So this is just the simple thing with importing data. Yeah. So we've imported Excel like that. Now for Google Sheets, we use a different package. Now this is why generally most of this programming language is about packages. We have the option here to import with Excel, SPSS, SAS, and what? Data file. We are not importing any of these, but we imported what we have here. Now for Google Sheets, since Google Sheets is online, oftentimes you need some form of authentication. But you need a package that can give you the capability to import this. And that package is the Google Sheets 4. Google Sheets 4, this package. So I'm going to load it with the library function, Google Sheets 4. And I'm running this. I have this. One thing to always do is to authenticate your Google Sheets. I have done that already, but to do it, what you do is what? You use the function gs4 auth, that's authenticate. Then you put your email there. So it's astudiassist@gmail.com. This is the one that I have access to the sheet to use. It's asking if I want to authenticate this. Yes, one, yes. And it's going to load this. And continue. Yes, authentication completed. Then moving back. Yes, finally it has been authenticated. Now if I click on it again, there's no difference. And that's because what? Authentication is already complete. Now next, we want to import a Google Sheet file. There's one I've prepared for this masterclass. Let me locate this. Now this is the inline safety data. And let me say, I have to make this public to everybody. So if we want to practice with this data, we can all practice without restriction. So anyone with a link can do that. Now I'm going to show us how to import Google Sheets files. You just simply copy the link, then you go back and you use the function read sheets. That's all. Then the next is to use the argument SS, which is the sheet link. Then you just paste it. This is ridiculously long. I don't want to introduce any other new things that can reduce the length, but let's leave it like this. So if we read it to try to, now we can see that it has even loaded the name here, airline safety. And also we can notice there's a problem from the start. Package 538, just problem. This does not look like a data I want to work with. Yeah, so we have to look at our sheets. You always need to preview this thing. And here we see that we have a metadata, the package, where this data is gotten from, the description of the data. So we have like about 7 rows that are not really paramount to the real data that we need. Important as they may be, but we do not need them. So we are going to skip 7 rows. Then we'll use the argument skip 7. And once we run this, voila, you have a very good name now. Airline, including, and all these other things that it's having. And that's how we import Google Sheet. But look at this. You see how long this is? Long and ridiculous, if you ask me. So I'll just delete it. So the other way we can import this, instead of using that long version, is to come back to your browser and you check the URL. If you look at this place, you have Google docs.google.com/spreadsheet/d. Now, anything after this /d/ just copy it down to the last place before you have this edit. Do not copy the /. Do not copy the /. Just this. This is the unique identifier of this sheet. So you just copy it and put it. And that's the sheet ID. So if I try this also, you see that we have the same thing. So this is how to import Google Sheets file. So I will call this airline safety. And I'll save this. Yeah, it's reading it and we are fine. We can preview this view, airline safety. And we have this right here. So that's good. Yeah. Any question before I move to data manipulation? I think this is some of the major things that we need to cover in this aspect. Things relating to importing them, using the right arguments, file to locate the parts, column names. Maybe our file is having column names or not, and setting names if they do not have column names. Also, we saw that we can import using links if you don't have the file locally, but of course it will have to download it. Then we saw how to skip rows or observation. We've seen how to skip that. And right here, we see how to import Excel file. I will saw also how to import Excel file and choose a particular sheet in 2 forms actually. So it's better I copy this and paste it here, because we can either use the sheet name or use the sheet number. Either works. Then after that, we saw how to authenticate Google Sheets using GS4 auths, then how to load Google Sheets. I'm not going to include that long link that I copied before. I'll leave it like this. That link is traumatizing enough. It's too long. Even this is traumatizing me like this. I better break it down so you see everything, because I think that is important, that you see all parts of the code at all times. So I'm going to break this down. Yeah. Now this is just my way of writing clean code. There are different ways to write clean code. If there's time, it's something that I would be covering in this masterclass. Yeah, but that's it. I don't know if you have any question before we go to data manipulation. Any question? Any question? Oh, well, I must be actually doing well for us to have no question. Now to data manipulation. Data manipulation simply means manipulating your data in simple terms. Well, for that, to understand what you mean by manipulation, we are going to work with one of the data which we've imported. We've imported a lot of data. We can start with adult data to begin with. So we take adult data, for example, and we simply load everything. Sometimes this can be too much. I mean, we can't even see some of the names. We have the information that this is having 15 columns here, but we can only see how many? 6, I guess. That means there are more. So to see all the names of the column, one thing we can use is we can use the names function, and we just enclose other data in it, and we have all the names of the column. So now I can decide, we can decide which to choose. We should choose some of these. And this is one aspect of data manipulation. It's what? Subsetting your data, or just choosing only select columns that you're interested in. For this, I'm going to choose age, work class, and sex. So for that, we take adults data. And now this introduces us to some dplyr function. And dplyr is part of the tidyverse. It's having a particular function that is called select. Now select, what select does is it helps us pick any column we're interested in, and it can pick it in different forms. I'm not going to go too in-depth here. You can pick only columns that is having a. You can decide to only pick the first 2, and for that we do like 1, 2. Just pick 1 and 2, and it will return 1 and 2. Meaning you can what? Pick with number. The other thing we can do is we can pick with their name instead of number. I want to pick sex, capital gain, and native country, like this. And you see that it is returned. That's the second option. Now, another way we can select or subset our data is to use data that meets like maybe certain criteria, or data within a range. For example, we have 1, 2, 3. This is 4 year. 4 year means 4, 5, 6. This is 4, 5, 6. This is column 6. This is column 4. So let's select column 4 to 10. Now it will be laborious to write 4, 5, 6, 7. No, it's too much. We should be lazy and not do that. So if we want to do that, we use 4, 10. We use the column, then 10. I showed us this yesterday. It's a neat trick, 4 to 10, like this. It's going to return 4, 5, 6, 7, 8, 9, 10. So it returns it for us automatically. So on selecting this, we have only those that are within the names, 4 to 10. Yeah. So 4 to 10. That means it ends with sex and it starts with education. And if we look at this, it's saying that it has 2 more variables, race and sex. So yeah, this is correct. So that's another way. Then the last one I'll just show you, which is also part of a box I do not want to open, is those that contain select. Maybe for example, that contain the word Sean. So I can use this contains Sean, TION, like this. And to return all the columns that contain Sean, we have relationship, occupation, education number, and education. So this is another way to select columns that we're interested in. But yes, enough with select. The next thing that we we usually do with data that we want to work with is to only select data that is having conditions that we are interested in. It is called subsetting. So to subset our data, now this is it? Give me a moment. What we've done here is subset by column, but now we want to subset by rows, or want to subset by the values or observation, rows, observations, or values, like that. So for this, we can, let's check our data. Okay, let me just open this data, adult data. And we have age, we have work class, we have, okay, let's work with education to begin with. Let's see people that, let's just return data for people that have bachelors, only bachelors. To do that, we'll use the function filter. Filter works best with values, with rows, and with observations. And with filter, what we want to work with is the education column. But now we have to set that this two equal to sign here is different from this equal to. This equal to is used to assign. This two equal to is used to compare. So here, what we are trying to do is we are trying to get values that are only equal to what? Bachelors. And once you press enter here, you see that it will return everything that is having only bachelors. As you can see, we have only bachelors here. But let's use the previous knowledge we just got. Let's select only age and bachelors because I do not like the long thing that it's producing. Okay. Bachelors, oh, sorry, not bachelors, education, my bad. Yeah. And now we have age and education. You see, we have bachelors. It's only bachelors that will return. Yeah, the other thing is we can filter now, not only by values that are exactly equal to something that we are interested in. This time around, let's work with age. Let's select age and education, and this time let's filter age for people that are less than 35 years old, or let's say less than 40 years old. Then we get all the values for people that are less than 40 years old. I will see that there are a lot, and that's good. What about if we want to match the conditions? Like we want to combine the conditions, we want to ensure that yes, the people want to select they are less than 40 and also they are less they have bachelor's degree. So to do that, what we'll do is we will use an operator now I'll be introducing. We have age, education here. Then we filter by age less than 40, and now we want to combine that of education. So we use and. Education is equal to bachelor's, like this. And yes, you see that we've returned people that only have bachelors that are below the age 40. This, we can combine any other thing with this. The condition can be any other thing, can be 40, less than or equal to 40. That means it should include exactly 40. If we run that, I think it's okay. Look at this. We have 3,039. And here we have 3173, meaning that it has included people with 40 years. We can print everything, and to print that, I'll just print, I'll use n is equals to 100, just to print 100 observations. And here you see, okay, I can't, okay, yeah, this is 40 right here. Here we can see 40. This is another 40 here. Suddenly this 40 has become more visible to me. So that's another way. Of course, there are still more tricks, more things we can add, but I don't want us to spend more time. The other thing we can do is, okay, maybe we should work with another data now. We have adult tests. Then let's see. Let's work with math score. Yeah. The other thing we can do is we can create new columns. We can get a new columns that will assign values to. It can be a combination of different columns or just converting another column to another form. It's best to show this. Let's check our math score and see what we have. We have this long thing, and this is quite long. So let's check the names of math score. Now there are some columns here. We have G1, G2, and G3. G1, G2, G3 is like that, over 20. That means the total score is what? Over 60 altogether. And I want us to choose the sex and the school. So what we do is what? Select sex. Okay, into this column. We select sex, select school, and we select. Now look how we combine this. Contains. No, I should not use contains. Starts with G. That way, it's going to return anything that starts with G, and that will be Guardian. That will be Gout, G1 to G3. So if I run this, you see we have Guardian Gout G1 to G3. But since this is not what we want, let me just remove this and choose G1 to G3 like this. And you see that it's different from using the number. Instead, I simply just use the column name and use this column to the last column I want to stop. All right, here we see that we have what was requested. Yeah, so now we have this, and let's work with this. I'll call this grade. Now assigning this to grade. Something we can do is we might be interested in seeing their total grade to see the total student. You have to create a new column. And to create a new column, there's a way to do this with this R, but it is quite easy. But I just want us to just use the tidyverse because it's intuitive. Yeah, as a part of the master of the bootcamp that we'll be doing in July, all these parts they'll be taught fully, both for base R and both for tidyverse. So you get to choose. And there are some other things that are being skipped here because the time that we have is enough, but we can't cover everything. That's just the truth. So the name of the function is mutate. And with mutate, you are trying to either change a column or create a new column. And in this case, we want to create a new column. So what we do is what we say total grade. And for that, we add G1 plus G2 plus G3, like this. And we have the total grade. 6 plus 6 is 12 plus 5, 17. This student is definitely not doing well. So one thing we can do is we can add another column if we choose to. Maybe we want to see the percentage, as that will give a better representation rather than the total grade. So we can use percentage score equal to. Now, instead of going to G1 plus G2 plus G3 and dividing it again, I'll simply use the new column that I've created here. This. I'll simply use this. So that will be total grade divided by 60. And yes, here we have the percentage score. I can multiply this by 100, so it's more relatable. So we see that this student is having 28%, and while this is having 75. This is nice. We have 88, and we have 28.3. This data is from a school in Portugal. It's just checking the performance of high school students based on various conditions. Yeah. Any question before I proceed? Because I see I've been going on and on for a while, and I do not know if you have a question. I do not want this to be one way. Any question? Okay. I cannot see any question on the comments. So if you do have a question, you can drop it on the comments. And also you can unmute yourself and ask your question. So moving on. Now we've seen how to select data, we've seen how to filter data, we've seen how to add a new column. And there are different things that we can do with adding a new column. For example, I can decide to turn, you see that these two, they are characters. I can decide to turn all of them to factor, a factor data type. This is something we didn't cover yesterday, but I'll just use it as an example. I think there are two ways to do this. The first one, we take sex, I will say sex equals to factor sex, like that. Then we take school, we say school equals to factor and school. It will give us the expected results. Now, the other way we can do this, we have factor, and we have what? This. The other way we can do this is to use a new verb. Instead of that, I will use across. That means I want to combine different columns. Now, across where is dot character. What this means is wherever character is, wherever there is character, I want you to convert it. Let's check grades. we have two characters in grade. So wherever we have characters, I want you to convert them to factor. That's what this means. So where is character? Factor. Like that. Oh, sorry. Factor. And we see that we have FCT and FCT again. So this and this is what? The same thing. Now let's look at the math score. We'll see where this is very important. This new concept I just introduced. And look at, we have characters. We have a lot of characters. If we check the structure of the math score table, we see that we have a lot of characters. Now let's just imagine that we want to convert everything. It's going to take, yes, or not yes, I'm exaggerating this time around. It's going to take a long time because we need to what? Select each column name, type them out, and what? Change it. That's where across is what? Very, very useful. Because all I have to do this time around is just take math score, for example, and I will mutate. And this time around, using across, I will set a condition where we have only characters. And here I'll convert to factor. Now I'll just pass this so that we can see the structure. Once we are done, I'll see that it has changed everything to factor. All the places that we had character, it has changed it to what? To factor. So this is where factor is nice. Yeah, so this is one other part with manipulating data. The other thing is we have data summarization. And data summarization means we are compressing data. And for that, I will introduce two concepts, grouping data. Now let's look at grades again. At grades, we have sex, school, and this, yeah. I can decide to group by sex. And if we group by sex, look at what we have now. We have groups, and it's saying that we're having two groups. That's what, male and female, like that. You understand? But grouping on its own is usually not that important. We need to do something with the group data. Of course, we can group more than one column at the same time. So we have more here. We have sex and we have school. So they are both having two. So I'll just reduce this back. So now, summarize. And summarization means that we want to compress it. For example, if we want to ask the question, like, okay, what is the total scores of students according to their gender? You can answer that question using the summarize. Let me go and copy something. Give me a moment. I will copy this data. Or assign a value to it. This data. Okay. I'll assign a new value to this data. I'll call it grades school. Yeah, like that. Now taking grade school as our new data now. We have this. I will see that the summary and the grouping is still working. But now we want to get the average percentage score according to gender. To do that, what we'll do, of course, we group by sex. Next, we need to check the average. So we say average score. This is just the name of the column. But the actual thing is what? We're checking the name of what? Percentage score, like that. And once I press enter for this, you see that it has been reduced. That's why it is called summarization. So at an average, the female is 51.6 and male is 55.4. But now this is a good insight. What about if we had a new column? Let me copy this and paste this here. Let's just group by school also. If we group by school to give us more insights. And grouping by school, you see that we have female GP 51.6. Now, if we compare the female in this school, MS, you see that they are performing better than the female, than the males in the school, MS. That's 50.3. But look at the males in GP. They are doing well compared to the females in GP. So this is what grouping does. And you can use this to answer different type of question. So summarization is also quite nice. And with that, we can go into the next part, which is reshaping our data. Before that, I don't know if anybody's having any question. Any question from anyone? Questions. Okay, no questions, I guess. Yeah, please, if you do have questions, do not hesitate to ask me. Yeah. So to reshape data, let's save this. Let's save this to let's say grades by school, grades by gender, like that. Now to receive data, we're going to take this as a simple approach. Yeah, so we have set, we have school, and we have average score. Now what we want to do is we want to separate the schools. We want to turn the schools to columns. So we just have only female and male, then we'll see their different score and their score. I think it's better to show this than explain. So for this, let's take grades by gender. And here I will introduce a new concept. It's called what? Pivot wider. That means I want to spread the data. That's what it means. And for that, I'll take the columns. I'll take the names of the data. Names from school and the values from average score. Like this. And once I do that, you see what we have. Now we have GP and MS. And you see that 6. Now it's just showing us, and this way it is easy to compare. It's easier this way than the other way. Yeah, so this is just one simple thing with reshaping data. And we can use this for more data. For example, if we check our airline safety data, we have this. Okay, this is a bit too short. There's more we can see. We have this long name here, which is annoying. But we have incidents 85, 89, incidents 00 and 14. Let's select. Let's just select the variables we're interested in. Contains incidents. Then I want to also choose the airline. And now we see 85, 99, and 00 and 14. This 00 and 14 actually means the year 2000 to 2014, while this is 1985 to 1999. These are the number of incidents scored with airline travels. So for this now, we can also use this function, pivot wider. Of course, there's another version of this function, pivot longer. So what we do here is what we take the names from. No, we are using pivot longer now because this data is wide already. We have 85, 99, and 2000 to 2014. So we are taking the names. Let's see. We first select the columns that we're interested in. So the columns we're interested in is equals to those that contains incidents, like that. Or better still, if you prefer, you can just use incidents 85, 99, then use incidents 00 to 14, like this. Then after that, we'll have to say where the names we go to. Names to, for this we use names from, that means where are we picking the name from? We are picking the name from school, and where are we picking the values from? Right here. Where are we picking the names from? We are picking the names from the school. This is the school names. Where are we picking the values from? We are picking the values from here. So the names and the value that appear, they'll be arranged accordingly. Now for this, where are we sending the names to? That is the column we want to send the names to. And that we'll call yeah. And also, where are we sending the values to? The name of the column. I will call that incidents. So once we run this, you see we have this. Now this, in a way, is not bad, but this does not look like a year. And now we see the importance of mutate, because with mutate, we can perform some operations. For example, we can decide to remove anything like incidents, or altogether just only extract the numbers. Yeah, so if we want to extract the numbers alone and just remove all these incidents, one thing we can do is we can use, of course, I have to select here. We can just use pass. Can use pass number. Then we put in the year. And once we do that, you see we only have 85, 0, 85, and that's because it sees the rest as what? It sees the rest as character. So if this does not work for you, the other thing is to use a more sophisticated option, and that's to use something from the Lubudate package. No, from the What package is that? String out package, since we are working with strings. And for that, we can either string remove, we remove anything that is like incident to begin with. Just remove incidents. You see that I included the column name. And from this column, I want to remove anything with incidents. Let me include the underscore. And here you see that I've removed all the incidents. Then I might decide to still work with the same column that, okay, still with the same year, the new one which you've created. I want you to replace all this underscore with space. So with that, I can simply say string replace all, then yeah. And what I want to replace is I want to replace the underscores and I want to change it to space. You can decide to do like this if you choose, and we have this, or you can just change this to dash if you work. But for some people, this might not be clear. Yeah, so this is another thing with data manipulation. You see that it just involves using combination of functions just to get desired results. And that's that with manipulation. So for the last thing we'll do today, we'll go to plotting. Yeah, we'll go to visualization. I think we should have spent more time on visuals, but these other parts, I think it's important we do understand this concept, even if it's for a short while. So for plots, yesterday we did a simple plot. Let me show, where's the script? Yeah. Okay, we have the scripts and we produce a simple chart yesterday. Okay, this right here. And this is just one variable alone. So let's increase the number of variables that we want to work with this time around. We can work with any of the data, but let's work with grades. Let's see, we have grades data. Yeah, and we have sex, we have school, we have G1, G2, and G3. So there's another version that is having the total. Okay, this one is better. So we can work with this. So something we can do here is, because there are different types of visualization in general, it's not just bar plots. We also have histograms. If we want to check the distribution, to check the performances of students, what we do is we also pass this to ggplot. And now if I go to compare the way I did this to yesterday, this is the data. The data is already in here. But today, the data is outside, which is grade school, and I'm just piping it. So what pipe does is it takes the what is on the left-hand side, which is this side, and it uses it as the first argument in the next function. In this case, data is the first argument in ggplot. So it replaces data and it sets data as what? Grade school. So the next thing I have to focus on then is the mapping. So with mapping, let me break it down. The mapping, we can define the aesthetic. And here we can say X or Y. And since it's just simple histogram, we can just say X equals to what? Percentage score. Like this, then we add, as said, it's a combination of components. Now we want to add what? The histogram, histogram of different geometrics. And once I press enter, we have this. This is nice. This is good. What about if we want to see the distribution according to gender instead of this? So what we can do in this case is we can add a new argument called field. Then we had the name, in this case sex. And once we do that, see that it has separated it. Now we have female, and we see the distribution of female. It seems a lot of females are having pretty good scores within the mid-range to the top box. The highest score is, I think, is a male, but females are kind of performing well from what I can see. We can just take a quick summary of our data, grade school. For example, we can decide to summarize. And this time around, I'll show us a different variation. Instead of using group by, we'll introduce the argument dot by, and I want to introduce dot by sex. Because this time around, I want to count the gender. So to do that, I'll say gender count, then n. N is a function that is going to count. And we see that we have more females than male. So before we conclude that females are better and everything, we should also realize that what? We have more female present than male. And we can also include another variable here, which is the school. I will see how the number varies across the different schools. I will see the female is usually more in all the schools altogether. It seems in Portugal, the females love to go to school than the guys. That's what I can tell from this data. But of course, I do not know the total population of the country, so that would be a wrong conclusion. Now, moving on to visualization again, continuing on what we've started, we can get the distribution of their performance. And to do that, we need box plot, because what box plot does is it gives us a distribution of a particular numeric variable. So what we do is we take grade school. I'll pass this to ggplot. I don't know if you can see this. Let me take this off. We pass this to ggplot. Then after, we start with mapping. And this time around, AES, we take sex, which is X equals sex. Then Y is equal to what? Percentage score. And now we have something empty. But once I add the geo box plot this time around, we have this. It's not the finest of charts, but it does provide answer. You can see in general that the median for the male is higher than that of the female. Also, we can make it a bit pretty and divide by color. Let me break this so we see better. Percentage. Then color is equal to school. Instead of color, you can also make it field is equal to school. And once we do this, we see this now, this time around. I can see the different school. And we see that this is, in a way, not bad, but we can decide to change the color. And to change the color, we use the function scale fill continuous. Yep. Okay. Fill discrete. And it's going to fill this, but this is just the default. We can define the scale here, the pellets. We can use set 3. Then to change the color for us, if it is set 2, changes the color. Of course, I can decide to change the color also, not just the field. But with that, I have to change this field to color. And once we do that, we see that it will be more uniform, like this. But something that is always nice to do is, if you want your plot to stand out, is you set the color right here. You remove it from here, and you set the color right here, and give it just one color. Color equals to black. Then the color will be black. Then this is better than what we had before. So this is just something simple that we can do. And what we'll be doing so far is just using default control. Now, another thing we can do is, instead of just separating them right from the mapping, we can decide to let them have their own different plots. So I'll copy this now, and I'll paste this here. And this time around, I'll remove the color, which is field equals black. And once I run this, we see that this is not working. And that's because field has been set to what? To nothing. I will include it again. Field equals to school. I have this, it fills this. Now I want this to have their own different charts. And to do that, what I do is I facet. Now the facet, I use facet wrap, and I use this tilde sign, and I facet with, for example, school. And once I do this, see that we have two different charts. This is different from what we had before. And now it's showing the boys differently, that, okay, yes, these are boys. Now this is confusing now because the field is by school. So we can as well just change the field to be by the sex. And if it's by the sex, we see that this is female and male, female and male. But in a lot of ways, it doesn't make sense. This chart does not make sense. The reason why it does not make sense is because while we have a color representation, we also have F and M here. F and M here, which makes it too much unnecessary information. So something we can do is we either switch this off or we remove this, one of the two. And before we do all that, one thing we can do is we can decide to turn this to the other way. That's if we want to. And with that, we use the cut flip. And once we use cut flip, we have it turning the other way, but we don't really need to do that for this. So I'm just going to set it back to what we had before. And now we can go back to what? Controlling the axis labels. So the first thing I'm going to do is, I think we can remove the legend. So to remove the legend, what I'll do is, I'll use themes. Themes is the function we use to edit and fine-tune how we want our charts to display. And what I want to work with this time is, I want to work with the legend. Legend.position, and I want it to be none. I do not want any legend here. Legend.position none. And we see that now the legend is off. Now it's making sense a bit. We know that this is female, we know that this is male. One other thing we can do is we change this. We see this is 100%. This is actually supposed to be percentage, but now we just have 100, 75, 50, and 25. For that, we have a function we can use, and for that function, we have a package we can use. That package is called scales. Let me import it first. Scales, yeah. Library scales. It's likely it's not installed. Okay, I have it installed already, which is good. Yeah. So with scales, I will try to edit this. So what I'll do is I'll take scale Y continuous. Then I will say I want the labels to be no, not this. I want the labels to be what? Percent. Label percent, like this. I can simply delete this and use this like this, and it should work fine. Okay, label percent. Breaks and labels have different lengths. Okay, let me set the breaks first. So breaks is equal to sequence 0 to 100 divided by 25. Then the label is label percent. Label percent. And now we say this is giving too much. So I'm going to change this to 1 instead of 100. So this is better, 100%, 75%, 50%, 25%. Why this is nice, we still have more things we can do. For example, we can change this name here, sex. Make it a bit better, but also we can as well just remove it. Because if we see F and N, we kind of, in a way, understand that this is male and female. Or we can as well just come here and mutate it from the start. And this is why I always like to put my data outside the ggplot in case I want to make any change at the beginning. So I want to change the sex. I want to make it a factor. And we have, the levels of sex. We have F and N. And now I want to change the labels. I'll break these labels. The label, no, not label groups. I want to change the labels to be equal to female and male, like this. So I can run this first, see what we have. There's a mistake somewhere. Showing me there's a mistake somewhere. Okay, this sex FN. Okay, there should be C here. And this should have its own. Now, once I run this, I have female and male. Okay, so running this now, this will change it to female and male. Since I have female and male, there's no need to have sex. I would also dare to say there's no need to have percentage score, because you can tell intuitively that this is percentage. So one thing to do is what? Is just remove the plots axis. Is to remove the axis. I have my comma, plots dot axis, or plot dot title. Remove all the plots title. Not plot title, axis title. Axis dot title. I make it element blank. This is just to remove it. And now they are gone. And this is better, because now we can tell this is male and this is female. And also we can choose to use a different theme. I think it's better I have that first. I can use theme minima. So it's having a more modern look than this. Okay, maybe this is not the best theme. Let me see which other one. Theme light. Can always choose a theme. Okay, this is not bad. So we have female, we have male, then we have the schools here. Then we can have title. So far, so good. We've not added any label. We've removed the legend because we see it as not necessary. We already have female and male, and we can already tell with the color without the need of having a legend. We can tell that this is a percentage, so we remove that name also. The next thing is we need a title to tell us what are we looking at. So what I'm going to do is I will add a label, and that's with labs, and I'll add the title, and I'll say distribution of students' performance in GP school and MS school across gender. Then I run this. And now we have a long title. Since the title is long, I can decide to what? Alter it, maybe by reducing the size. And something I can do is under this theme, I can change the base size. Change it to like 12, maybe to reduce this length, the size of this. Okay, and this is bigger. Let me make it 8. Let's see what we have. Okay, this has reduced it, and this is much more clear. I can decide to add other elements, like maybe a caption, for example, comma caption. Since this is too long, let me just break it, paste 0. So that's a new function. Not really a new function, but it's just a function to ensure that things that is too long, I can break it down and I can see it in the next line. So caption now. The caption, I can say data from UCIL machine learning archive. And I change this to data source. And once I run this, we have this. So this is just some of the things that we can do. And I bet you there's many more. There are more things that we can do than this. But this is just part of the capabilities. And now we have to think about the application of this knowledge that we use. It's not only limited to research or academia alone. It's actually quite important for people that want to be involved in financial modeling. I don't know anybody that is in finance. There are also functions for that. We have the quant mode, for example. That's like a package in R that is specifically for financial modeling. And also people that want to showcase what they can do. They can have this well packaged, which is something that we are going to do tomorrow. Something that is not packaged. Packaging all these things in such a way that it's presentable, where people can see what we are doing and they can reach through our chain of thoughts. You know, they said that show me your works. Instead of just telling me what you can do, show me your works. And that's what we'll cover tomorrow. Tomorrow we'll see how to present all these things so that it is accessible by everyone. One thing we noticed is the data for this masterclass I've made available. This I also make available. That means it's a way I can show what I've worked on. So the same thing you're going to learn. But other than that, there's something more that you can do. For example, let me just open this and just take it to a link. That's better. For example, you can show like your GitHub repository. That's one thing. And I think it's quite common now. That's what people do. But I think there's a better thing to do. Instead of just showing people code. Why code is nice, there's something more better than code. You can show them what you've done specifically. That's better. there you can show them like, okay, yes, this is what I use this particular thing for. It is better than just showing the codes alone. Now, this is like something that is typed out. And if there are visualizations, you are going to see the visuals all through. You are going to have things like this. And I think this is showing a bit of info. There are visualizations, different things. So this is something that I won't say we are going to learn this in the master class. That would be me not being honest, because it's going to take some time. But in the bootcamp, we'll learn how to present something like this. Yeah, where we'll show our work. Because people, you'll be surprised at how well people will be fascinated. CVs are no longer enough to show what you can do. They always say that, show me your projects. This is one of the best ways to show your projects. That's if you are looking for a better job, if you are looking for a new job, if you are looking for other things. Now, this right here is a visualization, and I think this is with Python. Yeah, this should be with Python. It's a page that is quite heavy. Yeah, everything right here is with Python. So it's just showing things that I can do. And similarly, it's something like this that you'll be learning in the masterclass. I won't say in this, no, not the masterclass, in the bootcamp. I'm sorry, because the masterclass is too short for us to do something like this. So all that we are learning is for a reason. But the main thing is, once you get any data, the main thing you should always ask is why, what, how. The how part is something that you can get online. The what and the why is what you want to ask on the data. Tomorrow, I'll take us through a way to work with new data, because oftentimes people do not know what to do when they get a new data. Yeah, so I'll take us through that tomorrow, what we have to do when we get a new data. Yeah, any question? Oh, I'm getting a question from Pascal. The sign before this cool. Oh, it's called tilde. This sign is called tilde. This is the sign. Tilde like this. That's the name. Then the other question, please, if you have any other question, please tell me. What's the duration of the bootcamp? The bootcamp is only weekends, and it's for 4 months. And the reason why it is 4 months is because I want it to be robust. There will be multiple projects. Multiple projects means that you have 3 or 4 things to show that you've done. So I think that is very important. Of course, there'll be a certificate, but more important than the certificate, there'll be sign that you've done something. It will be different from you just going through a program and having a certificate. It's better to show that you have done something coupled with the certificate. That is good. I do not understand the question. Is passport information very vital? It is stopping you from filling the bootcamp form. The bootcamp form. I'm not sure I understand gifts. If you can unmute yourself and ask, maybe I can relate.
Yes, sorry.
Yeah.
So I was trying to fill in join the bootcamp from the link I think you showed us yesterday in the video, the EU assists.
Yeah.
Something. I think there's a place like join here. So I saw that I couldn't proceed because of that information. So I was trying to ask if it was very, very compulsory.
I think it's better I just show this so I understand. Okay, this has after 2 years, it's already here. StudyAssist.com. Okay. You said, is it get study or join the bootcamp? That should lead to this page. Then you can join right here. You just click on show. Then, of course, please, there's also scholarship, and you can apply. But the scholarship is needs-based.
Okay, thank you. I think I missed it out there.
Or maybe you clicked on this, get study loan. And this is for people that
okay, maybe that's what I clicked. Yeah. Okay, thank you.
That's get study loan. Yeah, we do support students to the are traveling abroad and do need some form of aid to cover transitional costs. Any other question? Yeah. We are done with the main session now, and I'm going to stop recording, but I'm here to answer all questions that you have. Any question?